3.4, 3.5, sine and cosine, sinusoidals. Here we go.
So far in Unit 3, we have learned how to define sine and cosine values for angles and standard position, how to measure angles and radians, and how to use unit circle to evaluate sine and cosine functions at given angles. Now we will put all of these ideas together and discover that they can help us develop and understand how to represent sine and cosine functions graphically.
All right, we're going to graph these bad boys. Keep going.
Let's start by considering the function f of theta equals sine of theta. Since we know that angle measures in standard position are periodic, we can expect...
What does periodic mean?
One rotation.
What does periodic mean?
A rotation.
It's a cycle, remember? It keeps happening over and over and over. That's what the period is. All right, keep going.
Also, since theta is our input value, we will use the horizontal axis for our angle measures and vertical axis for our output values, f of theta. The angle measures from the unit circle gives us several convenient input values to use on the horizontal axis.
All right, fantastic. So let's think of sine. Sine deals with what? The y. All right, and so what is sine of 0? 0. Because it says 0, it doesn't go up or down, it says 0. All right, and then let's do sine of pi over 6. Well, what's the sine of pi over 6? 1/2. And so we got a 1/2 going on there. And so at pi over 6, it goes up to 1/2. All right, and so let's do it again. So let's do pi over 3 now. What's the sine of pi over 3? Square root 3 over 2. Why is it square root 3 over 2? Why is it the bigger one? Closest to the y-axis. All right, and so we got square root 3 over 2, almost to 1. And so we get pi over 2. What's the sine of pi over 2? 1. Why is it 1? Because it goes directly up. Love that. All right, and so let's do 2 pi over 3. What are we at? Square root 3 over 2 again. All right, and then at 5 pi over 6, what's the sine of 5 pi over 6? 1/2. And so down to 1/2. And then at pi, what's the sine of pi? 0. And so right now the curve is looking like this. All right, let's keep going. At 7 pi over 6, what's the sine of 7 pi over 6? Negative 1/2. Why is it negative? Because it went down. All right, and it's the y, so it's the smaller one. So now we're at negative 1/2 at 7 pi over 6. And so now we go to 4 pi over 3. Well, what's the sine of 4 pi over 3? Negative square root 3 over 2. And then what's the sine of 3 pi over 2? Negative 1. And then what's the sine of 5 pi over 3? I'm sorry. Negative square root 3 over 2. And then what's the sine of 11 pi over 6? Negative 1/2. And then what's the sine of 2 pi? Back at 0. And so when we connect the little dots, we have our sinusoidal curve of sine, just like this. And so I want to talk about this just a little bit before we keep going. Where does sine start? Sine starts where? At 0. And which way does it start going? It starts going up. And what does it go up to? What is the maximum of a sine function? 1. And what's the minimum of a sine function? Negative 1. But then after I keep going to 2 pi, it's going to keep on going forever and ever, and it's going to repeat this wave, this curve that it's happening here. All right, and so we have some more vocab to talk about. Grace, can you tell us the properties of our graph of sine? Midline.
Right. The midline is halfway between the maximum and minimum values.
All right. So a midline is a y equals something. It is not just 0, it is a line. So it's in the form of y equals, okay? And it's always going to be a horizontal here. And so it's like halfway in between our max and our min, okay? That would be our midline, y equals 0. All right, keep going.
The amplitude is the distance from the midline to the maximum or minimum.
All right, so I want you to put a little extra thing on this. An amplitude is always positive. An amplitude is always positive. And the reason why is because an amplitude is a distance away. And so is a distance ever going to be negative? No. Okay? And so this is why amplitude is always positive, and it's either from the midline to its max or its midline to its min. All right? So in this case, how high does it go up? 1. And it goes down to negative 1. And so the range of it's really negative 1 to 1. Or if you do a numerical sense, it's 2, right? but our middle is 0, and so we have an amplitude of 1. All right, keep going.
Period. P equals 2 pi.
All right, so our normal period of sine is 2 pi. It will complete its cycle in 2 pi. All right, a new verb, or a new word for us.
Frequency. The frequency is the reciprocal of the period.
Right. So last year I didn't have to teach frequency. This year I am, all right, because it's an AP class now. And so frequency is just the reciprocal of the period, okay? So what's frequency? The reciprocal of our period, all right? And so in this case for sine, it's just 1 over 2 pi, all right? And so let's keep going on this part.
The graph of f of theta equals sine of theta oscillates between concave down and concave up.
All right, so from 0 to pi, do you see how this curvature is concave down? And then from pi to 2 pi, we now have what? Concave up. And then guess what happens from 2 pi to 3 pi? Concave down again. And it will keep on going that wave after wave. All right, now let's talk about cosine. All right, so just like what we did with sine, we're going to do the same thing with cosine. Cosine deals with what value again? The x. So what's cosine of 0? 1. And so we got 1 where it starts out at. And then what's the cosine at pi over 6? Square root 3 over 2. And then at pi over 3, what's the cosine at pi over 3? 1/2. And then what's the cosine at pi over 2? 0. Why is it 0?
It doesn't move left or right.
It just goes up. It doesn't move left or right. Beautiful. All right, and then at 2 pi over 3, what do we got? Negative 1/2. Why is it negative? It moved left. Very nice. All right, and then at 5 pi over 6, where are we at? Negative square root 3 over 2. All right, because I went left again, but it's more negative. And then at pi, where are we at? Negative 1. We're on our axes. All right, so there's halfway. All right, keep going. So now it's 7 pi over 6. So what's the sine, or cosine, I'm sorry, cosine of 7 pi over 6? Negative square root 3 over 2. And then at 4 pi over 3, we're at negative 1/2. And then at 3 pi over 2, where are we at? 0. Why is it 0 again? It doesn't move left or right, exactly. All right, and then at 5 pi over 3, we're back at 1/2. And then at 11 pi over 6, we're back at square root 3 over 2. And then at 2 pi, we're back at 1. All right, and so when we connect our little dots here, we have this curve starting to look like that. And do you see how it will complete its cycle? It starts at 1, it ends at 1 from 0 to 2 pi. And so we have that sinusoidal curve just like before, but it's slightly different here. So where does cosine start? Cosine starts at 1. And what does it do first? It goes which way? Down. But sine started at what? 0 and started going which way? Up. That's really how I want you to start thinking of sines and cosines here. All right? And again, we have the same things going on here. We have midlines, amplitudes, periods, and frequencies. And then they're all the same between sine and cosine here. So if you look at the midline, in between my max and my min, I still have y equals 0 unless it's shifted. All right, and then our amplitude is still going to be 1 unless it's going to be squeezed or stretched. And then our period is 2 pi unless we mess with our period and our frequency. Now, the thing that I want you to look at right here is a sinusoidal function is a function that involves additive or multiplicative transformations of sine of theta. And the cool thing about sine and cosine is that they're both sinusoidal functions, even though like it says cosine and sine. They mean different things. However, if I were to shift the sine function back pi over 2, guess what it would equal? It would equal cosine. All right? And so that's
2 periods of this sinusoidal function f theta are shown in the figure above. Find the period, frequency, amplitude, and midline of the graph f of theta.
all right, fantastic. So let's look at this first one. What's its period? When does it complete one cycle? When does it complete one cycle? How long will it take? At pi. It completes its cycle in pi. So if you go from here to here, it completes one cycle. And so my period is pi. Now, its frequency, though, is going to be the reciprocal of my period. And so what's its frequency? 1 over pi. All right? And its midline is what's in the middle. All right? And so what is in the middle here?
Pi over 2.
No. 3. But we can't just call it 3 because that's just a numerical value. It would actually be what? Y equals 3. All right? Because it's really like a line. It is a line. It's not like a line. It is a line in the middle of that function. All right? All right, and then its amplitude. And so my amplitude is going from my midline to our max, or my midline to my min. And so what is the distance there between the max or the min? 3. All right? And so my amplitude is 3. Is amplitude ever negative? Never, ever. All right, let's look at the next one now. All right, so now I have this sinusoidal curve, and we're going to do the same thing. And so, Miranda, what is my period on this one? How long did it take for it to complete a cycle? Pi over 2. All right, and for me, I kind of looked from there to there. That's kind of how I did it. All right, and then its frequency. What's its frequency then? 2 over pi. It's just the reciprocal of our period. And then our midline. And so what's my maximum here? 3. What's my minimum? -1. So what's the average of my max and my min?
1.
It's 1. All right, and so now I have the line what? Y equals 1. All right, and then it's amplitude. And so it goes from my midline to my max or my min. And so what is my gap from there? 2. All right, pretty good in the hood? Cool. All right, let's look at this next one. Ethan's going to read this next one.
The sinusoidal function h of theta has a maximum at the point pi, 8. The first minimum after reaching this maximum value occurs at the point 3 pi, -2. Find the period, frequency, amplitude, and midline for the graph h of theta.
All right, beautiful. So if I have a max starting at pi, and I have a minimum, at 3 pi, did that complete its cycle? No. How much of the cycle did it complete? It completed half of its cycle, didn't it? Well, how long did it take to complete half of its cycle? It goes from pi to 3 pi. So what's half of its cycle?
1.5.
It goes from pi to 3 pi. So how long was that taking? 2 pi. It took 2 pi. But that's half of it. So what should I do with it? I multiply it by what? 2. And so my period is actually what here? 4 pi. All right. So its frequency is just the what of it? The reciprocal of it. So my frequency is 1 over 4 pi. Now its midline is in between my max and my min. All right. So what was my max here?
3 pi.
8. What was my min? -2. And so what's in the middle between 8 and -2? 3. How did we get 3? We take -2 and add 8 to it to get what? 6. And then we take the average of that. So we divide it by 2. And so now we have what? 3. However, I can't just call it 3. I need what? Y equals 3. And its amplitude is the distance from the midline to the max or the midline to its min. And so, what's my amplitude? 5. Because 3 to 8 is 5, or 3 to -2 is also a distance of 5. All right, so that could be a good way to check our midline there.
The figure shows a large clock mounted on a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. At times t equals 0 minutes, the minute hand is pointed directly up at the 12. However, the clock is not working properly and the minute hand is moving twice as fast as it should.
Oh dear.
Thus, the next time the minute hand points directly up at the 12 is at time equals 30 minutes.
All right, let's break it down. What's my period? 30 minutes. Okay, it takes 30 minutes to complete its cycle. All right. Well, what's my maximum here? 128 is my maximum. All right. What's my minimum? 112. All right. Because 120 is in the middle, and then we have an 8-inch second hand. All right. All right. So here we go. Or a minute hand, whatever. All right. So now we're going to label them. So what does F start with? F always starts at a maximum. Is everybody following me? Now, at time 0, is this one a maximum? Yes. Do they always start at the maximum?
Yeah.
No. Like your homework, it's not going to start at a maximum. It's going to start at a minimum. All right? It's going to go halfway around. But this one actually starts at its what? Maximum. So what's F? 0, comma, 128. Now, if we go Campbell style to solve for P, what is my P now? 30, comma, 128. And so now I like to do J next. And so what's J? 15, comma, 112, because there's where my minimum is. And so my minimum is going to happen at time 15. And so now we just kind of take the averages of them. And so G, what's that ordered pair now? 7.5, comma, 120. And then K would end up being 22.5, comma, 120. All right. Pretty good there? Cool. All right. So let's go to part B now. You got it.
Find the period, frequency, amplitude, and midline for the graph of each.
All right. So let's do its period first. So what was its period? 30. All right. We already talked about that. So we got 30 there. And so if it's 30 there, what would be its frequency? 1 over 30. I'm going to do midline next because it makes more sense to me. And so our midline is going to be what? Is our midline x equals something or y equals something? Y equals something. And so what is y equal? 120. Okay, it's like right here in the middle. And so our midline is y equals 120. And our amplitude is our distance from our midline to our max, where it's the average of our max and our min, basically. And so then, what would I be there? 8. All right, and so our amplitude is 8. All right, so let's look at part C now.
Find two intervals for which the graph of H is both decreasing and concave up.
All right, so we want decreasing and concave up. All right, and it says for 2 intervals in this one. So, F to G, am I decreasing? Yeah, I am. But am I concave up? No. How about G to J? Am I increasing?
No.
Or I'm sorry, am I decreasing? Yes, but am I concave up? Yes. And so that's one of my intervals. So this is what we're going to write. So we're going to say H is decreasing and concave up on the interval 7.5 to 15. All right. I want to use our t values here. Okay. And so I'm decreasing and concave up on 7.5 to 15. Okay. So we're using like our input values on this. All right. And so then let's keep looking. And so this is decreasing and concave up there. How about J to K?
No.
Nope. How about K to P? No. But how many did it ask for? 2 intervals. So I need to keep going. And this is where I would advise using periods. Okay? Because it's a cycle. Do you see how it's like over and over? It does the same thing over and over. And so you don't even need to see this part of the graph to get it. Now you can see it. Isn't this the same right here? But you didn't actually have to see that part, okay? And that's what I want to get from it. Because what's our period? 30. And so all we need to do is add 30 to 7.5, and we're going to add 30 to 15. Because it's going to complete its cycle again. Are you following how we use our periodic phenomena? All right? All right. And so now it'd be 7.5 to 15, and on the interval what? 37.5 to 45. All right.